This is an introduction to exercise 2G and 2H on inequalities and using formulas, page 111 and 116 respectively of your textbook. We're going to do now a question from exercise 2F based on worded equations. And in this question, we have Flora and Joe who raised $426 between them in a fundraising effort. If Joe raised 52 more than Flora, how much did each of them raise? There's two ways of doing this. How might we do this one? Any ideas? I like to go with using a little bit of simultaneous equations. That's my personal preference. If you have another method, for example, doubling and then adding 52, you're more than welcome to do that. But I'm going to stick with the simultaneous equations method. Let's define Flora. Let F equal to Flora's and then J equal to Joe's. I should say Joe's sales? Raising. I'll just say raising. Just so we're clear what they mean. So are we okay if I say that F plus J equals to 426? Are we okay with that? It makes sense. They both raised 426 between them. If Joe raises 52 more than Flora, so I'm going to write J and F here. If Joe raises 52 more than Flora, if I'm trying to compare them by level, of course Joe is higher than Flora, right? 56. So how do I make them at the same level? I could add 56 to Flora. Oh, sorry, 52, my apologies. Or I could minus 52 from Joe. Let's add 52 just to make it very clear. So if Joe raised 52 more than Flora, that means how much Flora raised plus 52 is the same as Joe's. Now that we've got two equations, I'm just going to put that in. So if I put this equation into here in replacement of J, I can say that F plus 52 in brackets just in case equals to 426. That means 2F plus 52 equals to 426. And then 2F, if I minus 52 on both sides, we end up with 374. Correct me if I'm wrong. Yes.
Is it?
No? Okay, and then I divide both sides by 2. 374 divided by 2. What's that? 187. Are we done? Are we happy with that?
No.
Why not?
You gotta calculate as well.
Thank you very much. We also have to calculate J. So, to do that, I know that J, I'm going to put that, Joe, sure. I'm going to put that into this equation. I should probably fix up that being a 5. There we go. So, if I put that in the equation and say J equals to F, which is 187, plus 52, which gives us an answer of 39. Sweet. Let's move on. I'll leave that up on the screen for you guys. I'll just zoom out a bit.
But you gotta write words.
Oh, thank you for reminding me. We do have to write it out in words. So, in this situation, we would say that Joe raised $239, remember units, while Flora raised $187. And that would be my final answer. Sure, full stop. Okay. Any questions about that one? No? So we constructed equations. You could construct a different equation as long as it's equivalent. And then we figured out by substituting, you don't have to do this method. We found the value of F, and then we find the value of J, and then we sub it in. Now, of course, I can't just write F and J equals to what. We have to write at the very start, F equals to what, and let J equals to whatever. Because otherwise, we're making stuff up. And if we're not explaining why we're making stuff up, we can lose marks for that. Okay, today's content, we're starting off with inequalities. So, equations are something you guys are already familiar with. Inequalities probably less so. In this situation, Greg, Kevin, and Greta think that they have all have the correct solution to this inequality, where 4x minus 1 is greater than or equal to, that's what this one means, greater than or equal to, x plus 6. Intuitively, inequalities just mean that we're not only saying it equals to something, but it could be greater than or less than something. If I put x equals to 4 in this question, I say, all right, 4 times 4 is 16, minus 1 is 15. So I've got 15 on this side. And then 4 plus 6 is 10. If I say 16 is greater than or equal to 10, is that true? Yeah, 16 is greater than or equal to 10. If I put in x equals to 10, so that's 40 minus 1, that's 39 on the left-hand side, and that's 16 on the right-hand side. Is 39 greater than or equal to 16? It is. There are multiple answers. We actually say there are a set of numbers that this is applicable for. And that includes decimal places. I could say 5 works. I could say 5.5 works. It includes the decimal places as well. So inequalities have a set of numbers where it's valid for. I want you guys to write this down in your notebooks, this section here. And again, if you can write it in shorthand, you're more than welcome to. In this situation, we're going to be using an open circle to represent greater than or less than. And we can differentiate that from the equals one because it has only one line, doesn't have a line at the bottom, whereas this one does. Sometimes you might see this written with the line horizontal. They mean the same thing. Okay. So an open circle means that's either greater than or less than. Now let's look at this example here while you guys are writing that down. This example right here. X is greater than 1. Well, of course that means that X could be any number. It could be 3, could be 5, could be 7. Can X be 1? No, because it cannot be 1. It has to be greater than 1, not including 1 itself. Which is why we represent that using the open circle there. So the open circle means that we are not including 1. Now at this stage, we're going to be solving them in terms of a linear context. Later on in future years, it's still important that we are able to understand inequalities, especially not including, for example, not including 1. Because that's going to come important when it's graphing more complex equations. If we use a closed circle, so just a dot, it means that we're saying it can equal to 1. So in this situation, we're saying x is greater than or equal to 1. We're still saying it has to be greater than 1, but it also could be 1 itself. So we symbolize that using a full dot or a full circle. Any questions about that? Okay. A set of numbers, as I mentioned earlier, may have both an upper and a lower bound. That is possible. And they don't have to be both greater than or equal. They could just be greater, for example. Or they could be this or different. In this case, we've got negative 2 is less than x, which is less than or equal to 3. So in this case, x is between negative 2 and 3. Are we including negative 2?
No.
No. Are we including 3?
Yes.
Yes. And so we can symbolize that using the open circle and the filled in circle there. Are you guys happy for me to move on? Or would you guys like to finish writing that one down? There's a lot of us, guys, don't all put your hands up at the same time. Are you guys happy for me to move on, or would you like to stay here for a second? Stay here? Lovely. I'll zoom in a bit for you guys to copy that down. For anyone watching the recording, just skip forward like 10 seconds. It's so meta, isn't it? So we pretty much treat linear inequalities the same way we do linear equations, but just with an extra rule or two. We're going to look at the rule when it comes to rearranging or transposing, these linear equations. I'll leave that up on the screen just at the top so that you guys can finish copying that down if need be. Alright, so linear inequalities are solved the same way as linear equations. However, and this is the most important aspect about linear equations when we're transposing, if we are multiplying or we are dividing by a negative number, we have to reverse the inequality. I'm going to ask you guys to write that down. If we multiply or divide by a negative number, I'm pretty sure I made it more difficult to read, didn't I? Then the inequality is reversed. There you go. I've used sparkly pen to make it look fancy now. Now you guys will never forget this. If we multiply or divide by a negative number, we have to reverse the inequality sign. Okay? I'm going to jump straight into an example. I'm going to ask that you feel free to ignore the first one in terms of writing in your notebook, but you have to write down the second example. It's a really prime example of inequalities. So let's say I've got x minus 3 is less than 7. Well, it makes sense that I just treat it as a linear equation and I just add 3 on both sides. So if I add 3, x is less than 10. Done. I'm happy with that. Did I multiply or divide by a negative number? No. I just added 3, so x is less than 10. For the next example, I'm going to go ahead and minus 5 on both sides because I have 5 minus 2x is greater than 3. So let's minus 5 on both sides and end up with negative 2x is greater than negative 2. Now, if this was a linear equation, what would you do to make x the subject? How would we make x by itself? Negative 2x. We divide by negative 2. If you'd like to divide by 2 and then negative 1, that's fine as well. But let's divide by negative 2 off the bat. If I divide by negative 2 here, divide by negative 2 here, I get x here, and I get negative 2 divided by negative 2. What happens to the sign? Yeah, we reverse it. We reverse it because we've divided by a negative number. Same applies if we divide by negative 1, negative 100, or we multiply by negative 100, same thing. If we divide or multiply by a negative number, we flip the sign. Which means that x is less than 1. Now I can test that, right? I can test that. I can say, all right, let's put in x equals to 0. That's less than 1. If x equals 0, 5 minus 2 times 0, so 5, is greater than 3. That looks good to me. If I ended up with x is greater than 1 and I test it, let's say I get, let's test x equals to 2. I get 5 minus 2 times 2 is 4. So 5 minus 4, which is 1. 1 is greater than 3. That's obviously not true, so we've done something wrong. Are we happy to move on to the next topic if I leave this on the screen? Okay. There we go. So the next topic is using formulas, exercise 2H. It's pretty much what you guys already know. It's just transposing, which means rearranging, to make something else the subject. When I say make something the subject, I mean put it by itself on one side of the equal sign. So, in this example here, and I'm going to jump straight into this example and I'll talk about that note in a second. The area of a trapezium is given by this formula here, where a equals to half of a plus b all times by h. Might seem familiar to you, might not, doesn't matter. If we substitute the values and then find the value of b, does it matter if I substitute and then rearrange? Or rearrange and then substitute? Does that matter? Will we end up with a different answer? No, we won't. But sometimes it's a bit easier to rearrange it when they're in the form of letters than simplifying after we rearrange before we rearrange everything. I'm going to ask you to take a look at this note here, where the square root of a squared is just a. The square root of a squared is just a. But that only applies if a, the number on the inside, is greater than or equal to 0. Does anyone know why a must be equal to or greater than 0? This is requiring you guys to think a little bit further, a little bit deeper. Yes?
Because if it's a negative number, then you have to...
No, that's right. Similar lining. A squared, square root of a. Because we can treat it as, would you agree if it's a similar line of thought as square root of a squared? Similar line of thought? Can I have the square root of a negative number?
No.
Not in the real plane. If any of you guys do specialists in a couple years' time, you might end up doing that, but we don't do that at all. We cannot have the square root of a negative number. Awesome. And then over here, second formula I want you guys to look at, or it's not formula, the rule. The square root of a squared plus b squared is not just a plus b. And you guys already know that from my Pythagoras rule theorem. A squared plus b squared all squared, so all square root, my apologies, is not just a plus b. Provided a or b is not 0. What does that mean? Why can't a or b be 0 for this rule? What happens if a and b are 0? Well, we'd have 0 squared plus 0 squared. Square root is just 0. And the right hand side we have a plus b, so 0 plus 0 is still 0. So if a and b are 0, they are the same thing. But we're saying for any other number, that is not true. Okay, let's give this a go. So, if I've got this formula, let's rearrange it, because we're trying to find the value of b, right? Let's rearrange it to make b by itself. So, I'm going to say, let's times both sides by 2. 2a, and then the 2 and the half cancel, equals to a plus b times h. Any questions about that? I've just times both sides by 2 to get rid of the half. Now let's divide both sides by h. So divide by h, and we end up with 2a over h equals to a plus b. Then finally, I'm going to say, alright, we've got the a plus b, I just want b by itself. Let's minus a on both sides, and end up with 2a over h minus a equals to b. Now that I've done that, I can just substitute the numbers in and not have to rearrange it. I could say, okay, well, a is 12, so 2 times 12, over h, which is 4, minus 5, which gives me b, which I know 2 times 12 is 24, divided by 4 is 6, minus 1 is, so minus 5 is 1. If you would like, you're welcome to put the numbers in and then rearrange. But sometimes it's a bit easier to rearrange it and then put the numbers in. Any questions? Okay, I'm going to leave it there. I'll go through these questions after the recording, if you would like. Otherwise, I'm going to let you guys get started